You're listening to the TES Maths Podcast with Craig Barton.
Hello, and welcome to episode 2 of the TES Maths Podcast with me, Craig Barton. I am delighted to say that this week I am joined by my very special guest, Alison Kiddle, former teacher and now the Key Stage 4 coordinator from the wonderful website Enrich. Hello Alison, how are you?
I'm all right, thank you, Craig.
Perfect. And we will be talking puzzles, problems, Enrich's fancy new website, and much, much more with Alison throughout the podcast. To get access to all the resources, links and ideas mentioned throughout this episode, as well as the forum discussion for this podcast, simply visit our dedicated website, and that is www.tes.co.uk/mathspodcast. And with so much to fit in, let's get cracking with our first feature. Despite what my pupils and my girlfriend may say, the world of maths is never dull. And there are a few recent issues I would like to look at in this episode that have been attracting a lot of attention in the bubbling and bustling TES Maths Forum and in the magazine. So I'm glad to see that I've got Alison in for this one, because a story that caught my eye was this whole thing about Cambridge University helping out with A-level maths resources. Now, the first time I saw this headline, I won't mention the media outlet that it was in, but it seemed to suggest that Cambridge University was going to take over the whole of A-level maths, completely redesign it and give us a brand new specification. Alison, can you confirm or deny those reports?
Well, that's not the case at all. The project, as it's been launched, is for creating resources for the current A-level in order to better prepare students who are going to go on to do maths at university. It's not at all about rewriting exam questions, and I'm sure your listeners will be pleased to know that it's not just dusty Cambridge University dons, but the Millennium Maths Project and my colleagues at Enrich are going to be fully involved in the whole process from beginning to end, using our expertise at writing resources.
Well, it sounds fantastic. And when are we likely to see these, do you think?
Well, the project is starting right now, and throughout the project, resources are going to start appearing on the Enrich website. So a few months down the line, we're going to be looking for teachers to get involved with testing things out in their classroom. So really just watch this space.
OK, and they won't be exam board specific, it'll be kind of general resources for across the whole A-level?
No, just like all Enrich resources, the resources that are developed should be appropriate for any of the current specifications.
Fantastic. And why do you think there's a need for resources like this for post-16 or A-level maths?
Well, I think the way that A-level maths exists at the moment, particularly with the modular system, there is a lot of pressure to get through a lot of work in a very, very short space of time. And sometimes some of the mathematical creativity and mathematical thinking can be lost because of the need to get students to learn to do procedures in an exam situation. So hopefully these resources will be more about the mathematical thinking and at the same time equip students to be able to pass the exams.
OK, and what are we going to do about this time issue though? Because I can just kind of playing devil's advocate here, I can imagine teachers turning around and saying, I've still got the same number of lessons, I've still got to get my students ready for that first exam in January. Where do I have time to fit in these rich problem-solving style resources?
Well, I think like all rich tasks, they don't need to be on top of what a teacher's already doing, but they can be used to replace some of the existing teaching. So because they're likely to be resources that link up lots and lots of different parts of mathematics, then a lesson working on one of these rich problem-solving activities can bring together different strands and maybe replace two lessons using a more textbook-based approach.
OK, well, sounds fantastic, and watch this space, and as soon as we at TES Maths hear anything about it, we'll be sure to let you know. For show and tell this episode, we're going to take a look at one of the biggest topics around. Algebra is undoubtedly one of the cornerstones of mathematics, and yet students can often have rather negative views of the topic, sometimes before they've even studied it. When asked which area of maths students find the most difficult or enjoy the least, algebra is regularly top of the list. Now, what I like to do when I introduce algebra to my Year 7 students is I'm avoiding collecting like terms and simplifying in brackets altogether, because I often find as well that students come to me and already they say, I can't do algebra, or my brother said it's dead hard, or something like that. So what I like to do is try and hook them in with algebra straight away. Now, there was a very interesting forum thread about this where people were sharing ideas for how they introduce algebra. Now, Gareth Fairclough uses the classic I think of a number, and he does a little trick on his Year 7s, and it's something along the lines of ask them to think of a number, ask them to double it, add 8, divide by 2, subtract the original, and then before they say a word, he tells them that they've all got 4 down as their answer. And to us teachers, it's a really obvious thing why it works, but to Year 7 students, that's fascinating. It's a trick. They don't understand what's going on, and they're desperate to know why it works so that they can try it on friends and family. And I like it. I like this about maths, when knowing maths gives you some kind of power above people who don't know it. And I talked about this with the probability thing last week, and I think that's really important. If you can empower students with knowledge, and that they're then desperate to show it to mums and dads because they've got one over on them, I think that's a really positive thing. So then what Gareth does is, once he's taught them why it works by introducing perhaps an n and 2n and all that kind of stuff, he then gets them to design their own puzzles and test it out on their friends and family. And I think that's a really nice way to hook students in with a puzzle or a problem like that. And now I'm going to try something a bit risky here. I'm going to try a live little puzzle on Alison on air. And I tried this over breakfast this morning, and it was an absolute disaster. I just tried it with myself, but I'm hoping under the pressure of the podcast recording, this is going to work. And this problem is from one of the most popular resources ever downloaded from TES. It's from Mathemagic, which has been uploaded by Maths126. And at the time of recording, it had been downloaded by over 41,000 people. Absolutely phenomenal resource, though I'll put a link to it again in our podcast discussion page, but I'm going to try Fibonacci sums live. Here we go. Alison, are you ready for this?
Yep.
All right. And I'm also going to need producer Claire's help with this one as well. So, Alison, can you give me a 2-digit number? Keep it reasonably small just to make life a bit easier.
Okay, 23.
23. And producer Claire, can you give us a 2-digit number as well?
63.
63. Now, what I'm going to ask Alison to do is I'm going to ask you to add those 2 numbers up to get a third number, and then add the second and third to get a fourth, and create a Fibonacci chain from those numbers, if that's okay. And what I'm going to ask producer Claire to do is just make sure she can come round and see these these numbers that are going to appear and get a total of them. And I'm going to try and beat Claire to adding up the total of those numbers.
So
okay?
I have to add together 23 and 63.
Absolutely right, to get your next number. So we've got 23 plus 63, and we've got 86. I'm trusting Alison's mental maths for this one as well. And Claire's going to need to just pop round here and just keep an eye on these numbers that are appearing and add them up as she goes. So we've got 23 plus 63 is 86. 63 plus 86 is 149. Again, we're hoping there's no mistakes going to be made throughout this. So this, you can play along at home. You can create your own Fibonacci chain with these at home. And these numbers are getting pretty big now. We're already up to 619. So we've got 23, 63, 86, 149, 235, 384, 619, 1003. Oh, I was hoping it wouldn't get into the thousands. And can you stop when you've got 10 numbers, please?
3, 4, 5, 6, 7, 8, 9. Last one.
And the last number that's going down is this. Now, there's a load of numbers there. Claire's tapping away on her calculator, but before she does, I'm going to tell you straight away that the answer is going to be 6,809, the total of those 10 numbers. Claire, can you confirm or deny that?
I'm adding the top one to the bottom.
All of those.
All of those together, okay.
Now, whilst Claire's adding those up, I just want you to be thinking how you might do this with your students and what they might get out of this. Now, what I've done in the past is I've set this as a homework activity. I've said to students, go away and think of 2 two-digit numbers and then create a Fibonacci chain. And then they come in the next day and show me this Fibonacci chain. I take one look at it and I say, I bet that totals up to this. and then I see their friend's one and I say, I bet that totals up to this. And the students are absolutely fascinated about why it works. And I'm not actually going to give the answer away about why it works. I'm going to let you log on to click through the links on the TES Maths podcast page and download the excellent mathematics resource to see why it works. But again, it's this whole thing that once students know why it works, they can then use this trick out on anybody they like. So Claire, can you show the answer on your calculator to Alison?
Here's the answer.
6,809.
And there you go. How did I do it? Well, you know what you need to do. Get downloading that resource. A couple of other things that I've come across. If you haven't downloaded this, then get it downloaded now. The Manual of Mathematical Magic by Matt Parker. Now, I did a WebWhiz video, number 23, on this, because it's an absolutely amazing ebook, again, full of these mathematical magic tricks. And what's nice about what Matt Parker does is he shows you the trick that you can perform with your students, and sometimes there may be card tricks, sometimes they're number tricks, and then I set my students the homework of figuring out why these tricks work. And Matt has all the maths behind it, he even has suggested questions in there, and it's an absolutely phenomenal book, and it just makes for a great lesson. And it backs up what myself and Alison are saying here about just hooking students in with it. Give them tasks that mean something to them, tasks that they can access, that aren't dry, and that show them that algebra is useful and it is quite fun. And I want to just quote this, what David Gale has said on our forum post, that what they do in his school when they introduce algebra in term 1 of year 7 is they don't do any of this collecting like terms or brackets. They give them 2 investigations. One is the classic 1089 one, and the other is about diagonal differences. And he starts to introduce the concept of proof as early as year 7, and students can grasp it. They see that algebra has a reason, it has a method. It's about problem solving, it's about understanding why things work. It's not about adding 2a to 3a, it's about getting to the root of why things work, and I think that's so important. There are a load of other suggestions about how you might introduce algebra from lots of our talented TES users on the forum, so please click through the link to that and you'll see loads of them there. So, Alison Kiddle, Key Stage 4 Coordinator from Enrich. If you were to meet someone who'd never heard of Enrich, how would you explain to them what it was all about?
Well, I'd probably want to tell them a little bit about its history, first of all. So it started in 1996 as online support for gifted and talented students. So the idea was that students might be invited to participate in something like the Royal Institution masterclasses, but there wasn't much follow-up for them after they did that. So it was basically an online club for keen mathematicians, and each month there were 3 problems published at the appropriate key stages, and students could send in their solutions, and then the following month the best solutions were featured on the site. And together with the Ask Enrich forums, it was a community for very keen, talented mathematicians. But as time went on, the focus of the site changed to include teachers as well as students, and to be about not just these little puzzly maths problems, but about rich tasks that can be used in the classroom, not just for gifted and talented students, but for everybody. And I would say that our aim now is to get rich mathematical activity into all classrooms for all learners, because whether you're in the top set or the bottom set, you have the right to have an enriching mathematical experience in your maths lessons.
Okay, now how about yourself? What's your background and what drives you to want to work for Enrich?
Well, after I did my maths degree, I knew I wanted to do something that involved lots and lots of maths, but I was also really passionate about communicating my love of maths to other people. So teaching seemed like a natural place to start. And throughout my teaching career, I was desperate to get the kids to love maths as much as I did. I mean, I loved recreational maths when I was a kid. I always enjoyed things like mathematical origami, and I would try and bring as much of this into my lessons as I could. And when I discovered the Enrich website, I thought it was such a fantastic resource. So in 2008, when I saw that they were advertising, I thought it would just be perfect for me, because I'd be able to still use all my teaching skills, but to communicate this love of mathematics to a wider audience and really try and change the way that teachers thought about rich mathematics in their classroom.
Now, a question for you is a question that I'm often get asked whenever I talk about Enrich. Do you honestly believe that these puzzles and problems are suitable for all students of all ages and abilities? Because I would hazard a guess that a lot of the time they're used predominantly with gifted and talented younger students, perhaps top set year 7, top set year 8. Have you got activities that will work with disaffected year 11 students on there and get them loving maths?
Well, I'm going to pick you up straight away because you used the word puzzles.
I did, of course.
And we're not a website of puzzles. There are 1 or 2 slightly puzzly activities on there if you look hard enough. But it's about rich tasks. There are a lot of investigative tasks. It's about exploring mathematics. And we go right the way from early years foundation stage all the way up to the beginning of university level maths. So there's material on there to cater for all ages. And because we have this philosophy of what we call low threshold, high ceiling tasks, it really is suitable for anybody. So what I mean by low threshold, high ceiling is that we have tasks that everybody can get started on, so they have a very, very simple opening context. And they can be taken up and become incredibly mathematically complex. So if you have a real bright spark in your classroom who just happens to get hooked on it, they can take it as far as they want. There's lots of different styles of task on the website. So if you had that disaffected year 11 class, then you're going to have to do revision with them. And you're going to have to revise things like mean, median and mode. So instead of giving them a page of questions on mean, median and mode to practice, give them our and M task, which is very simple. It just tells you if the mean is 4, the median is 3 and the mode is 3, and I have 5 numbers, what could my numbers be? And it's so different from what your disaffected year 11s might be expecting that just the surprise of being presented that might be enough to get them interested.
I think you're right, because, and I think the key is that low barrier to entry, isn't it? It's the key with any problem, and I know you don't like the word puzzle, but any problem or any task, they've got to feel that they can get so far with it, and they've got to see some kind of light at the end of a tunnel and want to progress. And I think a lot of the content that is in the textbooks or that they're going to face in the exam, there is a perceived barrier there for students, and confidence is so important in maths, I find, that if there is a barrier up and their confidence is pretty low, they're not going to want to make any attempt to progress at all. So if you do have tasks that have this low barrier to entry, I think you're onto a winner there. So have you got a favourite task?
Yes, I think my all-time favourite task on the Enrich website, I'd actually like to have a go at it with you now, if you don't
after
mind.
After my Fibonacci attempt,
it's called Summing Consecutive Numbers, I first met this task when I was teaching, and my then head of department introduced a departmental meeting with it one day.
Okay.
And he then moved on to the important business like set changes and exam entries. And I didn't listen to a word he said because I was trying to find an algebraic proof for a result.
So this could be the end of the podcast if this hooks me in, maybe. Okay.
But you'll just have to suspend everything for a while and come back to it after we've finished recording.
I'll try. Okay.
So, can you just give me a number, please?
Any number at all.
Any number you like. Fairly small, so I can do the maths.
Number 8, please.
Number 8. Now, 8 is a very interesting number, and I wish you hadn't started with that.
Oh, okay.
So could you give me a different number?
Yeah, of course. 14.
14. 14 is a very interesting number because I can write it as 2 plus 3 plus 4 plus 5. So it can be written as a sum of consecutive numbers.
Nice.
Can you give me a different number?
Bigger, maybe?
Yeah, if you like.
23?
23. Well, 23 is interesting because it's 11 plus 12, so it's the sum of 2 consecutive numbers.
Okay.
Another number?
30?
Now you see 30 is quite interesting because it's 9 plus 10 plus 11, so it's the sum of 3 consecutive numbers.
Very nice, okay.
So I'm hoping that you're now thinking to yourself,
I'd love a number that wasn't the sum of...
Why did she not let me have 8?
Oh, why did she not let me have 8?
What's special about the numbers that can be written as a sum of 2 consecutive numbers, or 3 consecutive numbers, or 4 consecutive numbers? So all I needed to introduce that to you was a pen and paper. All you would need in a class is a whiteboard and a marker. And there are so many questions that the kids can ask. And one technique I like to use when I'm working with students is to say, what questions might a mathematician ask next? So it's not what questions interest you, because you might fold your arms and say, well, I'm not interested in this at all. But by having this imaginary mathematician creature, what would this mathematician be interested in exploring? And he would want to know what's special about 8. What's special about the numbers that can be written as a sum of 2 consecutive numbers? What about the 3 consecutive numbers? Is there a rule that I can use to help me to write something as a sum of consecutive numbers? How did Alison manage to answer so quickly when Craig gave her these numbers? What strategy does she have for figuring out what these consecutive sums are? So it's such a simple entry point to a task, but you can get into some really lovely mathematics from it.
That's nice. Can I advise all users just to press pause now, because their minds will be buzzing with this and they won't be listening to anything we say for the next 5 minutes or so. That's lovely, that. And I assume you'll put a link to that on the podcast page?
Yes, I certainly will.
And I'll link to it from our thing. That's fantastic. How do you know that these Enrich activities work with students and not just teachers?
Well, we are lucky enough to have some very close partnership schools who've worked with us in the past, and they've invited us into their classrooms, and there's been occasions when we've maybe taught somebody else's class for a day, or they've got in touch with us and written little reports on what they did. So you can read on the Enrich website about actual teachers' experiences of using these tasks, and they don't pull any punches. If something didn't work, they let us know, and then we put that in the teachers' notes and say, perhaps take this teacher's advice on board. We also really like it when teachers blog about using our tasks, and we've got a few links on the website when teachers have blogged about what they've done. But I know there are loads and loads of teacher bloggers out there who listen to your podcast, and it would be lovely to hear from them if they've used any Enrich tasks.
What would you say the overall aim or mission of Enrich is? What changes do you hope Enrich is making and will make in the future to how maths is taught and learnt?
I think, well, from my point of view, I want children to experience what it's like to be a mathematician. So I'm very, very lucky in that our offices are based in the maths department at the University of Cambridge. And sometimes schools will come on visits to us, and I'll ask them the question, what do you think a mathematician does? And a lot of children think that what a mathematician does is really, really big sums. So maybe with thousands or even millions columns in their thousands, hundreds, tens and units, and they'll add maybe 5 numbers together instead of just a couple. And of course that's not what it's all about. So I want children to experience things like making conjectures and justifying and reasoning and noticing patterns and ultimately proof, so that they have some sense of what mathematics actually means to mathematicians, rather than the pale imitation that school maths can sometimes be.
Okay, and if we've got teachers listening here who have heard a bit about Enrich but they've never tried a problem, would you recommend trying one of the ones you've mentioned here, or is there any other one that springs to mind that you think, as a teacher, go away, I'm going to try that in my classroom tomorrow, I'm going to try that next week?
I think the one problem that everybody always goes away and tries with every class when we share it is the factors and multiples game, which is a perennial Enrich favourite.
So I would like to offer a massive thank you to Alison for joining us and being such a fantastic guest. And just a reminder that all of the puzzles, although I shouldn't say the word puzzles, the problems and rich tasks that Alison has mentioned are available on the Enrich website. And the address for that is enrich.maths.org/TES podcast. And I will also place a link in the document that accompanies our page on www.tes.co.uk/maths podcast. Thank you so much for joining us, Alison. Okay, so now time for our final section of the episode, which is, of course, the podcast puzzle. Now, last episode's puzzle generated a lot of feedback on Twitter, with people offering me quite large sums of money for hints towards the answer. Let's see if this one has the same effect, and I'm pleased to say that it's going to be kindly presented by Alison herself. Alison, over to you.
Okay, so this problem is called pair sums. 5 numbers are added together in pairs to produce the following answers: 0, 2, 4, 4, 6, 8, 9, 11, 13 and 15. What were my 5 numbers?
What were the 5 numbers? So if you've any thoughts on that, you can either go onto the forum discussion page that's linked to via the podcast. You can go join me on Twitter, that's at TES Maths. I'm sure we could do a bit of the at Enrich Maths on Twitter, and also go via the Enrich website. So loads of opportunities to show off how brainy you are there. So we have reached the end of episode 2 of the TES Maths podcast. Just a reminder that you can find all the information to the links, resources and ideas discovered at our website. That's www.tes.co.uk/maths podcast. And next episode, I will be joined by Jeremy Hogden from King's College, who will be discussing some amazing rich tasks that are perfectly designed for Key Stage 3 and Key Stage 4 students. So please join us then. Bye for now.